Alright, going live very late. So I guess it's just for the European types and such. And I guess I should open the other window just to verify things. I should change the damn title too. Anyway, I guess I'll change the title. Alright. What's today's date? I don't know. I'll say it's something like the 3rd or something. Ugh. We'll just pick a number here. What's this number? 5. No, that's too high. We'll go with something lower. Ooh, 4. Too many 4s. Alright. Yeah, that should be right. So we'll go with that. And this won't be Star Trek BS. This will just be... yeah, they're wrong and I'm right. Yeah, that's what it'll be. Anyway. Alright, let me just get that done. Sorry. You could jump ahead. I mean, this is, just a little bit of maintenance I have to do because of the way the computer and YouTube works. It doesn't let me do things on my own channel, so I have to do this crap. To view, to be able to moderate or even see the chat, I have to go through this procedure and such. Alright, so here's the live video. I should be able to just click on that and that should be enough. That's alright, so here's the live video. Yeah, okay. Good enough. Alright, let's see. Maybe I'll do the pop out thing just for the fun of it. Where's that again? No, it's not there. Yeah, the pop out thing. Where are you? Doesn't say anymore. Oh, it's probably up here. This menu. Okay. Pop out. Yeah, there we go. Alright. I think I'm done fiddling around. So, yeah. So just for the Europeans. So I did think I did sign up for the Demystify Psi podcast. Their what the hell's it called? Yeah, something. What the hell is that stupid thing called? I just hate getting old. I mean, these little. I mean, okay, look, as the things go, it's not the end of the world, but paradigm drift or something. Paradigm drift, yeah, that's it. So I did sign up, and they didn't immediately reject it. So we'll see if I'm able to actually participate. Oh, is the volume working? Yeah, okay. Sometimes my microphone is disconnected for no good reason. And so you get 1 minute, and I'm saying, oh man, there's so many subjects I could do. I could do the silly. There's no. I think I'll try to stick in the 1 minute somewhere. There's no such thing as it taking 25 times the fuel to move something 5 times as fast. If I'm in space, I don't need 25 times the thrust. I don't need 4 times the thrust to go twice as fast. I don't need 3 times the thrust to go, 9 times the thrust to go 3 times as fast. None of that happens. So it's just, we know it's bullshit. It's not right. So the theory has to be broken. It isn't right. I don't, I have to say this over and over again. And you're just saying, there aren't any people on this planet who are honest enough to say, yeah, okay, that's a pretty good piece of evidence. I mean, if it doesn't do what it theorizes and says, if the reality doesn't do what the theory says is supposed to be true, the theory can't be true. It's done. It's cooked. Get over it and move on. But they won't do that. So, yeah, so and so now I'm thinking, okay, I really should just, the fact is I have an everything theory. It's a theory of this is the elemental function, and once you have the elemental function, you have all the function. There's one universe, the smallest universe, and that one makes all the other universes, so to speak. I'm not doing a damn thing. Electrons and protons are doing it. And they're doing it because of the way the matter gets confined into these machines, these objects. And it just really has nothing to do with big me thing. It has to do with what a bunch of little tiny things are doing based on how they get manipulated by a force and how the force ends up manipulating them. All right, so anyway, so the simple truth is the universe, I like the Sisyphus analogy, so I'm going to go with that. And so basically it's just the argument's going to be is there's two kinds of Sisyphuses in the universe, okay? And it doesn't matter what their difference is. We'll just say the difference is going to be red and blue. And they move the speed of light when not pushing boulders. So when they're on their own, they're flying through the universe at this preposterous speed. But when they bang into a boulder and have to push it, all right, then they're going a lot slower. So there's two kinds of Sisyphuses, and there's two kinds of boulders. Okay, there's red boulders and blue boulders. And we could just argue that the red boulders are a lot heavier than the blue boulders, and so they are harder to push. You know, go as fast. But the simple truth is when a Sisyphus is pushing a boulder, okay, it doesn't go the speed of light anymore. It goes a lot slower. Okay, so the velocity is way down. And so there's only these interactions. There's just Sisyphuses flying at the speed of light. See, I'm way over a minute. Yeah, so I really have to, I have to figure out how to do this in 1 minute. Well, anyway, this is what I'm going to try to do in 1 minute. Well, I have it drawn ahead of time, and then maybe I can't draw it. So it makes it even harder. Oh, I'm not even allowed to draw it. Okay. Well, anyway. And so the simple argument is when the Sisyphuses can either push the boulder or be reflected because the boulder's already being pushed. See, two Sisyphuses can't bang into or push the same boulder. So you can't have two Sisyphuses. All right. Only red Sisyphuses can push red boulders, and only blue Sisyphuses can push blue boulders. That's the rule. I'll tell you what happens when one of those try to do the other. But anyway, but two Sisyphuses can't interact and hit the boulder and be pushing against each other. That's a reflection. So anytime the boulder already has a Sisyphus on it and somebody comes from the other side, they just both reflect. Okay, so all you have is a Sisyphus stays and pushes, and if there's another Sisyphus already here pushing this way, then he just joins him, and so you can have multiple Sisyphuses pushing the same boulder in the same direction. All right, that's a possibility. So the boulder goes faster and faster and faster, and maybe it gets close to the speed of light. And then the Sisyphuses obviously aren't losing much of their fun because they're not having to push very hard each one, so they can keep going very fast. But when there's only one of them, yeah, it's a slow voyage. Okay, so there's either push the boulder or bounce off the boulder. And then the other third option is if there's we use the blue one. If there's a blue boulder and you're a red Sisyphus, okay, what happens is you go in red, okay, and you come out blue. There you go. So with those simple rules, okay, those simple rules create a perfect diagram of electrons and protons. You end up with boulders, okay, we'll call that one the electron, I guess, and we'll call this the proton, and you end up with boulders that are exuding a force, okay, Sisyphuses. So there's Sisyphus bouncing off, constantly going in, bouncing off. Then there's blue ones coming in, coming out red. So you can see that there's just Sisyphuses coming off of this object. So they are at equilibrium. The Sisyphuses are coming from all directions, and this is what you end up with. So red and blue comes in, all right, and only red comes out. And for this one, the same truth. Only blue comes out for the blue one. All right, for the electron, I'll just mark that. E, you can't really see it, doesn't matter. And proton. And that's all there is. And so now you have your charges, and the charges are essential. So you can sort of understand the red Sisyphuses coming out of this red one can't do anything to the blue. They just get turned into blue Sisyphuses. And the blue Sisyphuses just get turned into red Sisyphuses. So there's no pressure between them at all. but all the red ones out here are pushing this way, and all the blue ones over here are pushing obviously towards the red, and those pushers will keep pushing. So obviously the two get pushed right into each other. And you can also understand that if I had two reds next to each other, that these red syphicases will push on each other. So they're going to shoot syphicases at each other. They're going to end up pushing and reflecting. So they're going to create a tremendous amount of force. And then all the blue ones coming from this direction and this direction get converted into reds. And so it makes even more pressure. So you'd understand why the reds are going to push apart very well and the blues are going to push apart very well. So it perfectly creates charge. It explains why electrons and protons behave the way they do. A simple particle model explains it completely. And all you need is this, and then you start making dipoles. And once you start making dipoles, you can make, well, tripoles. But you can make what's called a deuteron next, right? First you make a neutron, an electron and a proton. Then you end up making, well, it's drawn backwards here, but you end up, well, I might as well just draw it correctly. One electron, two protons. And you can understand that the protons get stuck in the nucleus because they're heavier, so they don't fly around as much. And so they can't go places, but the electrons can. So anyway, but that's what you end up. That's the building block of the nucleus. And all you do is start putting those things together, and you're off to the races. And let's understand, hydrogen in its common state is hydrogen 2, okay? And hydrogen 2 would be just, electron, proton, electron, proton. All right, so you can see the obvious building block elements here. And so once you have these elements, then it's easy to just take the next step and you just put two of these together and you end up with a helium nucleus. So I end up with, two electrons, and whoops, I didn't want to do that. And then I end up with, 4 protons, and can't really draw it, but the 4 protons would be here, 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 and here, the ends of the pencils. And the 2 electrons would be out here. And so there's perfect attraction. The 2 electrons are repelling. All the protons are repelling each other. And you have a very stable object. And that's the helium nucleus. So, just saying, you just keep adding one of these elements, a neutron and a proton, and you just keep building the next atom, the next atom, the next atom, the next atom. That's, now you have chemistry, then you move on to biology, and it's all made out of these simple element and these simple rules. That's it. So the whole universe, everything, all this complexity is really just interactions between a little pushing force, a very discrete, tiny elemental pushing force, and 2 material objects that interpret that force oppositely. And that's it. And this also, both of these objects are going to be doing the same thing, which is they're going to take a force that's going the speed of light. Okay, it would go a great distance in, a second, and they're going to turn into a force going a lot slower than the speed of light. And that delay perfectly explains gravity. Because both of these things, all of these electrons and protons, as soon as they're moving, because they're getting pushed by syphicases, as soon as they start moving, even if they're just moving back and forth, they're using the force to do that. And so if the force is being used to make this slow motion, it means it can't get to where it should be, the outside of the Earth. And so there's always a differential between the pressure coming from the outside and the ability of the syphicases to leave from the inside. So there's always more syphicases heading in than are heading out at any one moment. And the way it goes even again is you have to turn off the ones coming in and let the Earth radiate the ones it's absorbed. And the heat of the Earth isn't old heat. It's constantly fueled heat. You have to constantly put new sificuses in to keep the things moving. They can't stay moving on their own because they're constantly radiating out. So you have to keep putting in new energy to keep them moving. And that's why there's a differential, and that's why there's 9.8 meters per 1 second of gravity. Perfect answer. Now, the drag question, particle gravity can't work because of drag. I've solved that also, so there'll be a simulation soon demonstrating there's no drag. If I just obey these simple rules that I just described here, there's no drag. You can move into the force all you want, as fast as you want, and you just can't change how much force is coming this way. All you do is change when you hit it. You can't change how many sificuses there are. You just change when you hit them. It doesn't change anything. Changing when you hit something can't change how much energy it is. All right, so you just can't drag. There's just no possibility. You have to actually, when you have an extra force coming from this way, the only way you undo it is you have to add another piece of force coming the other way. The only way to undo it. All right. Yeah. So it's going to be hard to put that into 1 minute. Yeah, really hard to put that into 1 minute. But anyway. So maybe I'll leave it there. Again, I shouldn't have to argue anything more about mv squared than to just 1/2 mv squared, the kinetic energy theorem, than to just state there's just no frickin' reasonable evidence supporting the notion that it takes 25 times the fuel to make something go 5 times as fast, or to spin 5 times as fast. It's not a plausible belief. It's as implausible as a Holy Ghost, or antimatter, yeah, or bent space, or all the other implausible crap they believe. But I mean, there's just no way to believe it and be a credible, to make a credible credibly testify that somewhere you saw that happen, because I can't find a single place on the internet where they show that to happen, because it doesn't happen anywhere, anytime in reality. It doesn't happen. Just amazing that 350 years believing a fable for which there's no credible evidence. Nothing. I mean, it predicts things that clearly don't happen. And then I wonder, well, why is it so hard to get them to understand these new theories? Well, because they don't even understand how bad their old theories are. They can't even figure this out for themselves. That doesn't happen. I know it doesn't take 25 times the gas to go 5 times as fast. I just know that doesn't happen. And I certainly know that, physics says that, all I have to do is throw twice as many baseballs out of a rocket to make it go twice as fast. I don't have to do anything more than that. And I know it only takes twice the energy to throw twice as many baseballs out of the rocket. So it's an irrefutable proof. I mean, there's just no way to refute it. It only takes twice the energy to throw twice as many baseballs. You're throwing them the same speed as the first group. And it's just an absolute fact that it will double your speed. And it's an absolute fact it won't take 4 times the energy. So there's just no possibility that 1/2 mv squared has anything to do with reality. And I'm saying, you people, none of you are reasonable enough to say, I get that. That's a decisive proof. we really should quit arguing about this, because that's a decisive proof. I mean, it's just a fact. I mean, just think about it. If I'm in space and I'm relatively moving, but I'm not moving, from the camera's perspective, and I throw a baseball, I'll get a certain velocity. If I throw a second baseball exactly the same way, I have one in this pocket, I have one in this pocket, I throw it exactly the same way, I'll get exactly the same added momentum. Nothing more, nothing less. I'll double my speed. Do you understand that that can't be 4 times the energy? Throwing 2 baseballs instead of just throwing 1 baseball can't be 4 times the energy. The theory says if I go twice the velocity, I have to use 4 times the energy, because I somehow now have 4 times the energy. Can you understand it can't possibly be true? Are any of you honest enough just to say, yes, I get it. It really doesn't make any fucking sense. Oh, God. It is amazing. It's amazing to me how intractably religious science-minded people are. They just will not. They have a dogma. They believe it. They have to hold on to it for some reason. They have to cherish it. Everything a scientist says is true. Oh, scientists love. What is it? I mean, I found it incredibly easy to look at religion and say, silly story. Why are you making this distinction and saying, well, it's okay for scientists to tell me silly stories? Why? Why is that okay? Shouldn't silly story be the problem? Not whether they're wearing a lab coat or a preacher robe? I mean, should it make a difference what they're wearing? Shouldn't the character of the story be what you're going to judge? And isn't the character of the story suspect? All right. Yeah, so that's probably enough of a video. See, I wasn't planning, I just thought, okay, make a video just to do something, and that's all I did. So I'm just giving you a heads up. I mean, I am going to try to get on that stupid podcast. Man, and Frank, look, I can't even understand that, right? Apparently it has a ton of Patreons that are just piling in the money because they can do all kinds of things. They have all kinds of technology, they travel all over the place, do all this shit. But it gets crap views and it's garbage. I mean, the funny part is the two people seem so much smarter than all the people they're interviewing. And it's just like, why are they bothering? I mean, and most of the people are just doing some kind of UFO thing. I mean, the science is terrible. I mean, I would just watch the Wolfram one, and it was just insane. You're just saying, how can anybody... He spent 15 minutes just rambling about how you can't do the calculation because there's too much... And so because you can't do the calculation, there's no calculation. No, of course, the universe can do it. We don't have to do it, right? You don't need to know where all my stuff is to recognize that where all my stuff is matters. And whatever's going to happen in the next 5 minutes is really going to matter about where all my stuff was right now. That's going to decide what the next 5 minutes is, right? If I have a virus eating my brain or something, all of that matters. And so, yeah, it's all predictable. It's just that, yeah, okay, of course, you can't know where every electron is and where it's going. And so you can't do the calculation. Well, so what? The idea of the model works, that the apple falls down from the tree. I can make the experiment much simpler and then say, okay, this I can do. But the fact that we can't know where every electron is and what every electron is doing, we can't measure it, and we can't see it, and we can't establish it as a truth, doesn't change the fact that we know it's obeying rules and that the rules don't change. And he's implying that somehow the rules could change, but we can't prove it because we can't see it. So therefore, we can't tell if the rules change. But the fact is, the model will work. If I do this model, if I simulate this, it works. The simulation I've done, helped. What's the word for it? Commissioned. It works. It does exactly what I'm saying it does. This happens. The Sisyphus model works perfectly. I'm going to prove that the drag model will work perfectly. Reliably. It doesn't randomly fail. It doesn't do anything. It doesn't create some other outcome. It's very predictable and it works. So once you establish that you actually get the right rules, then you can be perfectly assured that, well, even though I can't see all my electrons, I can know that they're in a certain condition and that they're going to do a certain thing, by the laws of probability. Well, whatever. There's just no reason to play this game that because we can't do a calculation, that the calculation is somehow fudgy. No, it's not. Oh, shit. So anyway, it's just terrible, incoherent babble. You can't believe that there's a following for incoherent babble, but there is. The world is so fucked. Alright, so I think that's enough, right? I don't think there's anybody chatting, so I think there's no point looking for that. But I'll just go find it real quick and see, but I doubt it. Nope, no chatters. Okay. So, I will say goodnight and call it a video. And such. So, till the next time. I'd like to say something nice, but there's nothing nice to say. I mean, you're all belligerent idiots. I'm on a planet covered in belligerent idiot. It's really, really fucking depressing. I mean, college-educated belligerent idiots. Shit.